Jack Marchese, video homework 3, November 22nd, 2024. We're computing the line integral of this graph. First step is to parameterize C1. R of t equals 1 minus ti plus 2tj. This gives x equals 1 minus t and y equals 2t. You got to take the derivative of each of those. In order to compute the line integral of C1, you got to find the vector field. F of RT equals 1 minus ti plus 2tj. Take the derivative of r, which is equal to negative I plus 2j. Take the dot product of f dot dr, which is equivalent to negative 1 plus 5t. You then compute the integral of negative 1 plus 5t, which results with negative t plus 5t squared over 2 evaluated from 1 to 0, since those are the t values for the problem. That results in 3/2. We then need to parameterize C2. It's the parabolic curve of degree 2, meaning y equals 2x squared. Got to find r of t. R of t equals ti plus 2t squared j for t values of 0 to 1. Take the derivative of r. That leaves us with I plus 4tj. Take the derivative of x and the derivative of y, which is 1 and 4 respectively. Compute the dot product of f dot dr, which leaves us with t plus 8t cubed dt. We take the integral of that and then evaluate from 1 to 0. Doing so gives us t squared over 2 plus 2t to the 4th. Evaluated from 1 to 0 is 5/2. All right, now for method 2, using the elliptical path, we got to parameterize it using polar coordinates. F of RT equals cosine ti plus 2 sine tj. Take the derivative of r. That leaves you with negative sine t plus 2 cosine t. The dot product of f dot dr, you can see the algebra right there, is 1/2 sine 2t. We are using the identity that sine t cosine t is equivalent to 1/2 sine 2t. We do f dot dr, which is which comes out to being 3/2 sine 2t dt. Integrate that. The integral of that results in an answer of 3/4. Then we use another method. We use the fundamental theorem of calculus. Using the fundamental theorem of calculus, do the cross product of the gradient times f, which comes out to 0, meaning f is conservative. That's one way to do it, but another way to do it is also the curl test. Doing the curl test in the bottom left corner of the page, we see that the curl is 0, which also further proves that it is a conservative function. We do the integral of f dot dr. This is the fundamental theorem of calculus. You do the endpoint minus the starting point, which is 2 minus 1/2, which gives us an answer of 3/2. We then verify the results. The results for C1, the parabolic path, and the FTC approach all agree that the answer is 3/2. The elliptical path is different, 3/4, due to the parametrization, further proving that the line is conservative. That's the end of problem 1. For problem 2, we are doing a closed triangle that C1 is from 0, 0 to 1, 0, C2 is from 1, 0 to 0, 2, and C3 is from 2, 0, 2 to 0, 0. All right, so the first step, we got to parameterize C1. We get R of t equals t plus 0j. Take the derivative of that, which equals 1. Then compute f dot dr, which equals t. Integrate t from 1 to 0. You get the result of 1/2. For C2, we get x equals 1 minus t and y equals 2t for t values of 0 to 1. R of t equals 1 minus ti plus 2tj. Take the derivative of that. Then you compute the dot product. C1, C2, and C3 will all be done very similar, just different numbers. The dot product is negative 1 plus 5t, which you will then integrate from 1 to 0. And the answer to that is 3/2. We then do C3, where we find x is 0 and y is 2 minus 2t, meaning r of t is just 2 minus 2tj. There is no x value for this. Take the derivative of that, it gives us negative 2j. compute the dot product, f dot dr, we get -4 plus 4t, which we will then integrate from 0 to 1, leaving us with an answer of 2. Sum up the line integrals. According to the identity, they should be equal to 0. As you can see, they are. Check if f is conservative. Similar to the first problem, we're just going to do the curl test here. The curl test results in 0, so you know it is conservative. Then find potential functions. Doing so means we will find the derivative of f with respect to x and the derivative of f with respect to y, which is x and y respectively. We will then integrate the derivative of f with respect to x, which leaves us with x squared over 2 plus g of y. The derivative of f with respect to y is also equivalent to g prime y equals y, so g of y is equal to y squared over 2. You plug that into the result of the integral of the curl test of the partial derivative of f with respect to x, meaning f of xy is x squared over 2 plus y squared over 2. Then we use the fundamental theorem of calculus. This states that the total line integral over the closed path C is f of endpoint and minus f of start point. The end and the start point are the same since the path is closed, so the potential difference is 0. The total line integral of this question is 0. That is all. Thank you very much.